This is a Jamb physics problem, and it says that a uniform beam HK of length 10 meters and weighing 200 Newton is supported at both ends. A man weighing 1000 Newton stands at a point P on the beam. If the reactions at point H and K respectively are 800 Newton and 400 Newton, then the distance HP is. So let us sketch the beam. So the beam will look something of this nature. This is the beam. Yeah. So this beam total length is 10 meters. And the next thing is that it's weighing 200 Newton. Now, take note of something here. When you say an object is weighing a particular thing, this meter rule has its own weight. But there's an important information here, which is the fact that this is a uniform beam. A uniform beam HK, meaning that we have H at this end and we have K at the other end. If something is uniform, uniform means that the mass is evenly distributed throughout. And then the weight of an object always acts at their center of mass. Center of mass of an object is not necessarily the same as the center of that object. For example, by mere inspection, if we look at this now, we would say that somewhere around there is the center of this object, such that this side will be 5 meters long and this other side will be 5 meters long as well. Now, this does not necessarily mean that this position right here is the center of mass of this object. Why? Because if the object is not uniform, their geometric center is not necessarily their center of mass. However, we are lucky here because this object is a uniform beam. Therefore, the weight, which is 200 Newton, will be acting at its geometric center, which is also going to pass as the center of mass of the object. So the weight acting downward, we have 200 Newtons. But mind you, it is not always so that the weight will always be at the center if the information that this is a uniform beam is not given. Now, the next thing we want to do here is that we want to put they said that the supported at both ends, meaning that there's a pivot here and there's a pivot at this point as well. So with these two pivots, one thing you should always note about pivot is that for every pivot, there's always a reaction. There's always a what? A reaction. What I mean by that is that there's going to be a reaction going upward from this pivot here. So let me call that reaction at H. And there's also going to be a reaction going upward here. Let me call that one reaction at K. So even in all the equilibrium of forces question, taking moment that we always solve, and then we always ignore that there's a reaction up here. There was still reaction. There will always still be reaction. Just that oftentimes we don't need to consider them. But note that anytime you see a pivot, think about an upward reaction at that pivot. What are we going to use this for? Very soon we're going to take note of that. Now, we're even given the values of this reaction. We're told that at H and K respectively, we have a reaction of 800 newtons, and here we have a reaction of 400 newtons. Now, the next thing we're told here is that a man weighing 1000 newtons stands at a point P on the beam if the reactions at point H and K respectively are. So now we can place this P anywhere we feel like. I can place it here, I can place it here. Now, regardless of where I've placed it, all I need to know is to be able to find my distance from that end. So let me call the distance. So let me just place it here. I'm intentionally placing it here anyways. So to show that where I place it does not matter, let me call that distance. Let me call it distance X. So let me call this point P. The distance we are looking for is HP. So once I solve for X, then what I'm solving for is already solved for like that. Now that I've gotten everything here, it is time for us to take our moment. To take the moment about this point, first we identify all the forces that are capable of taking acting on this beam. We have number one, the two reactions at, okay, I did not put this other one. So we have a force of 1000 newtons acting downward here. So if you count all these forces that could act here, we have the reaction 1, the reaction 2, that makes 2 of them, and we have these 2 downward forces, which is 200 and 1000 newton. So we have 4 of them that could act on this guy. Now when you have 2 pivots, this is the idea. What you want to do with 2 pivots is that you want to actually forget about one at a given time. Forget about one at a given time. Now, so you can decide that I want to forget about K and consider this. You can say I want to forget about H and consider this. So what I'm going to be doing is that I'm going to be forgetting about this this one right here. I'll forget about K and I will deal with this other one. Now, of course, I'm forgetting the pivot, but I'm not going to forget the reaction, the upward reaction that is happening there. So the pivot I want to reference is this guy here. What I'm going to do is that I'm going to take the moment about this H. Immediately, I can forget about this reaction here because taking the reaction, the moment of this reaction about this pivot will just give me 0. So I don't need to bother about that. So the 3 forces that I'm left with would be RK, 1000 newtons and 200 newtons. So let's take the moment about that point. Now, if I fix my thumb at this place and I try to act in this direction, so label your clockwise and anti-clockwise. So we have clockwise and we have anti-clockwise. So let's see. Now, this 400 newtons, if I place my pivot around here and I try to act in the direction of this, so what we notice is that this will turn in this manner. The beam will turn in this manner if I place my finger here and I try to act in the direction of this RK. So, and what direction is that? That is an anti-clockwise direction, So I'm going to put this here. So the moment will be 400 multiplied by the perpendicular distance from here to here is 10, since the length of the beam is 10. So that's 10. Now let's go again. We have 200 here, still fixing this place and taking the moment about this point. If I take the moment about this point and I act in the direction of 200 newtons downward, how would the meter rule turn? The meter rule will actually turn in this manner, and this is a clockwise thing. So I'll put it here. That will be 200 multiplied by, what will be the distance from this 200 to this place? That is 5. I think I already established that. Plus, finally, we have the 1000 newton. The 1000 newton, we are still using this pivot. I fix this pivot, then I act in the direction of 1000 newton. Where will it turn? From what we can see here, it will turn in this manner as well, which is another clockwise. So, but the distance from this P to the pivot is X. So that will be 1000 multiplied by X. Now that I'm done with everything. Of course, if we want to take the moment about with this RH, the distance from this place to this place will be 0. So that is why we are ignoring the pivot, the reaction at the pivot we are dealing with. Now, according to the principle that we know, principle of moment, sum of clockwise moment equals to sum of anti-clockwise moment. So if we sum everything here, we would have 200 times 5, that is 1000 plus 1000x. And then if we sum what is here, that will be 400 times 10, that will be 4000. So these two must be equal, which implies that we'll have 1000 plus 1000x equals 4000. And this implies that 1000x equals 4000 minus 1000, that will be 3000. And this implies that x equals 3000 divided by 1000, and that will be 3. We're given this in meters, so that will be 3 meters. So which implies that the distance between H and P is 3 meters. So you can see that even though I had placed this thing something beyond 5 meters, which on a normal day wouldn't make sense correlating with the answer that we just got, which is 3 meters, but it doesn't really matter as long as I have done my arrangement properly. So which implies that this P is supposed to be somewhere around here, and that's just it. So X is 3 meters. If you like to see more videos like these solving Jamb physics problem, I would like you to give me a subscribe and follow me as well. I'll see you in the next one.